I hope that I can ask you some provocative question here, but I think the first thing that I wanted to talk about has to do with the form, because clearly you use a kind of a 70s era's Volkswagen and a whole of a speedboat. So I'm just wondering what is the meaning of that, and specifically because, because the Volkswagen has a kind of I would call it a lineage to it, right?
Yes, sure.
It's original. It has a certain kind of iconic form, and the speedboat has its indeterminate lineage. If it is of a lesser pedigree, except that you kind of put them together. Is there any specific meaning that you?
I'll start with the first meaning. The first meaning was like, boy, we got to get something quick. We need a car. We need something we need a form. We need something with a lot of shape. We need something that's like readily available. We need it now. So Craigslist. And $300, and we had the car, so it was readily available. That was definitely one of the things that drove it. But of course, there were there was other criteria, and aside from just being readily available. So
we could have picked a lot of, we could have picked anything. I mean,
You wanted to junk out.
No, we didn't go to a junkyard. We went to Craigslist, but we could have picked anything.
Like $300, what kind of car can I buy?
Sure. I mean, it's something. It's got to be. I think we settled pretty quickly on a VW Beetle because it was iconic.
It is iconic.
It's iconic. It also has a fair amount of double curvature, which we thought would be interesting from a technical challenge to mold.
Yeah.
And also, it's a symbol of mass production. I mean, it's one of the first cars that became kind of a worldwide icon.
Yeah.
And we thought it would be recognizable by anybody.
Right.
Because knowing that the shape would not be, we weren't quite sure how this was going to turn out. We didn't know what it was going to really look like as a inverted form from the inside. So we wanted to make something that was clearly of a particular era, that was a particular body style, particular car that people would recognize. If we'd have used something that was a little more obscure, maybe you would just be saying it's a car, but in this case, wow, it's a VW bug, I'd recognize that. But it's a symbol of, it's a symbol of mass production, and this is a very highly handcraft method of production that's overlaid over this symbol.
So is there a commentary that you have to say that it is because it is so handcrafted while you're doing something which is like, use a form of a mass produce, and because clearly I think the iconic shape of the piece is there, but it is iconic because it is a combination of the two, right? Because I would have to say that the form itself, if you really look at it, you kind of almost precisely, this imprecise technique, because it's like very handcraft, but at the same time it's very, very precise the way the object almost hit the ceiling of the gallery. And I look at that and I say, that looks like a rocket ship ready to take off and blast it through the ceiling of SCI-Arc, but you call it the observation tower. Mary Norris was just telling me how it could look like, it could be like a tanning salon with all of those lights.
But it is a tanning salon.
It is a tanning salon.
That's what we put on these projects for us. You're right. Yes, at one point we described it as an observation tower, but the project. But
what do you observe? What do you observe? There's a hole right through there.
That's an old explanation.
Ming, that's the problem with the modern press, is that you can put out and that's the problem with design versus highly craft-oriented things, is that you put out you have to put out the press release a month and a half before the object hits the it opens. So
And a few things change.
leaves you no opportunity to
But
change.
regardless of whatever, whether it is a tanning salon or a or a rocket ship, because I mean, if you start looking at that, it is alluding to the rocket ship because of the pointed, because of the
Definitely.
hole. But at the same time, a rocket ship is not a primitive object, and I would call this kind of a aboriginal kind of feel to that. It feels like a kind of a Sputnik old Russian rocket ship, right? And I wanted, I actually wanted to find out why the primitive overtone. Does it have to do with the process?
Yeah. I mean, the form of this thing is just all related to the process. I mean, we had these two objects. We had scans of them, and there's, for what we wanted and what we did basically to be able to work with these things, and the reason why it fits in the space the way it does is because we have very accurate, measured information of them. The images that are back here are basically three-dimensional scans of these objects. So then we were able to assemble them together digitally in the computer before we brought it here. So I think
the survey. So this is interesting to me because you're using a very advanced technique, which has to do with a 3D scanning.
Yeah.
Right. So you 3D scan the hole, you 3D scan the Volkswagen to assemble them digitally. However, the process that you made, because you have photograph here, and I remember at one time you have the VW, which is wrapped in foil outside, and you put the foil over the car because you want it to be. You use the VW as a mold, and the foil was a way for the to release, right? And so that is a very, very old technique, to use to deform the mold. Is an old technique, thousands of years old. And then at the same time, you are combining this with a very advanced technology, which is this 3D scanning. What are you trying to get out of it? Because the two right now don't seem to be speaking to each other.
Well, one of the things that definitely happens is, I mean, the car was a 1973 Volkswagen, so this thing's like, close to 40 years old. It's a pretty darn old car. So, the car has bumps and dents and all of those things. So the scan allowed us to get very specific dimensional information of that object. Even though it's an object of mass production, it's been, it has a history of use now. So it's like, it's like we are. It's got stars.
So was the Volkswagen in perfect condition, or did it have dent and accident?
It was $400 for a reason, $300 for a reason. Had no engine, rust spots bigger than my fist in places. So no, it wasn't perfect.
But on the other hand, you can't really tell.
Correct.
In this piece.
No, you can't.
So
but that's because
where is the precision and the imprecision comes in?
The precision in this case comes from when I have to explain the history of the process. We set about doing this not knowing how big one could cast a panel of paper. That may seem like a strange thing to say for a lot of people, but there is no playbook for the production of architectural scaled paper panels to our knowledge. You guys have proposed it, I know.
Yeah.
We did
which
it.
is the project,
Yeah.
but you didn't end up prototyping it at full scale. So
But we prototype full-scale panel. Yes.
Yeah. Okay. So we didn't have any knowledge of how to do this at this scale. So when we began the process, we had an opportunity to work with these guys in London who make these scans. And our thought was, let's get the scan, and then we have three-dimensional data of the object, the car, the boat. There was also a swimming pool that was under consideration, and then there was a 20-foot tall muffler man. Sometimes they're used as Paul Bunyan.
Which I found another guy exactly the same, different paint job.
There was a company in Venice, California that made them in the 60s. So we had the three-dimensional data of this. It could be then used in any way that we wanted. That gave us the freedom to subdivide the surface. If we wanted to subdivide it every 2 feet on center to make really small panels or larger panels, it was really something that we could decide while we were involved in the process of developing the project. We wouldn't, because the ribs in this piece are derived from digital data of the shape of the car. Sure, you could template that and you could get that shape, but if we were to do twice as many, it would be a real pain in the ass to template that. So, this gives you much quicker feedback. It enables you to design the panelization more rapidly. It also gives you the opportunity to study how the cars work in aggregate with one another within the gallery space.
It would have been very difficult otherwise to get. I mean, we would have had to. We could have played with it in more kind of abstract. We could have gotten a digital model of a car, Volkswagen, but
right.
It wouldn't have been very specific to ours. So then that data or the information, in a sense, for us wouldn't have been. We could have used it for sketching, but we wouldn't have been able to use it to build. So that's why the scans were very important, because they were very specific to the objects, and then we could use the data as not only for putting together concepts, structural concepts, ideas, spatial kind of concepts for this thing, but also, I mean, we could be very specific to those objects.
So basically, the 3D scanning was a way for you to understand how you can build up the spline and the structure, and then divide it up the panels so
Sure.
that they
Yep.
would have the structural integrity.
That's right. I mean, yes, absolutely. And yes. But bear in mind also, we were thinking these pictures represent this. When we began this, our intention was, at first, we set out to do an entire kidney bean-shaped swimming pool that was going to be inverted and become a dome in the space.
So the scale has something to do with the way you are able to produce the piece.
Yeah.
Definitely.
Because actually I wanted to then talk a little bit about the fabrication of the panel themselves, because the color fascinates me. It's clearly the color was used as a way for you to gauge the thickness of the material as you're applying the pulp, and
Meaning because it's recognizable and you could tell how much when you cover it, you could tell how much you've covered.
How much you cover, which is an old technique of when you do an auto body. You fix a car and you start laying bundle, and each layer is a different color because this is how you understand how many layers of bundle do you have, right? So it is a way for you to understand how thick and how thin and how many layers do you apply the pulp. But you decided to leave and to present the project as it is, with a lot of multicultural overtone to that.
To the color.
Yes, to the color and to the way it looks, because it is almost kind of aboriginal in the way.
We talked about.
Well, or like cargo coat.
Yeah.
Which about cargo coat, which they is in the Pacific South. I don't know if anybody knows about cargo coat, but this is in New Guinea, in Micronesia. This is after the World War II. So this tribal would build after World War II. They would then start building airplane and landing strip, out of straw to represent a manufacturing to.
Well, they were also seeing them as gods,
there's all of this
weren't they?
overtone to that. So what do you think? I mean, if people start reading about this, because there is a certain kind of specific reference or metaphor of your piece. You have to own up to it. It's like it is. It looks like what it is, and people are going to be thinking about those.
I know that the airplanes they were praising them. They were like they thought, because they had never seen an aircraft before, and to them when they first saw Air Force landing B-17 somewhere there, they were like, where is this from?
Where is this from the sky? So do you want everybody to react this way to your piece?
I don't know if the forms or the shapes were that had that same kind of power for us.
But it does have a certain reference to it, a specific reference to it, as a matter of fact, right?
When we stopped thinking about the pool, we decided, well, we still want to go for something that has a kind of, because the pool is going to create a kind of space, a kind of underside of this pool. And then we thought, okay, well, that's too ambitious. Our first thought was, let's make a kind of endless column.
So, we did, in essence, make the pool was the very first object that we started, because the pool had its own set of criteria. First of all, you had to find a swimming. We were interested in the iconic shape of the swimming pool, especially a kidney bean swimming pool in Southern California. So then we had to find an empty swimming pool, which turns out to be not that easy, especially with summer kind of coming up. And then, we ran
we had to con a friend of ours into doing it almost. Not con him, but he did.
It took a lot of talking him into it. Yeah. So nobody wants their swimming pool emptied twice and then sprayed with a bunch of sloppy paper all over it. But they were like the process in a sense, in the object selection kind of evolved in that sense, because we started with the swimming pool being the very first object, and it was perhaps the most ambitious object. Also because the swimming pools, it's a thing. It's not like the Volkswagen that which you can move around. It's a much larger thing. So the swimming pool definitely taught us that what we couldn't achieve in a lot of ways, because it was
couldn't achieve in this amount of time.
Couldn't achieve in the amount of time, and also the scale and the form of that thing had a lot to do with it.
Well, I was going to say that actually the swimming pool and how you use whether the Volkswagen or the Hulk is of the speedboat is very different, because one of the things is that you use we're talking about technique here, because you have a mold, and there's a male mold or a female mold, and so the swimming pool obviously is going to be female. It's going to be extremely difficult for you to build that. And I think that not only the scale, but to build something which is reverse, and you have to begin thinking about it. Then going back to the 3D scanning, how does that actually help you?
On a pool?
Yes, to begin thinking about doing the thing in the opposite. You have to.
The pool is of such a scale that would require subdividing it into, I think we had it subdivided into probably 50, maybe 75 separate panels.
Yeah.
You can't pull
right.
a panel off of a swimming pool that's the size of a swimming pool. I wish you could, that'd be really great. But you have to divide it and rationalize its geometry and make it into bite-sized morsels, if you will, that fit together in a very logical, rational way that can be reproduced or reassembled in this context. So the scan on the pool was even more critical, because you're making a rib structure that fits within, we're getting very technical here, but you're making a rib structure that fits very tightly to the surface of the swimming pool. And that rib structure becomes the part lines for the panel system. It's less complex, or the bug is less complex, the boat is less complex than the pool.
Well, because most of your work are very hands-on. Right?
Yes.
You build, there's a craft aspect to that. So how do you see how do you see yourself going forward when you start jumping that scale and testing out things which has to rely less on the hands, which I think you still do. I mean, all of your work still relies on that.
Well, I mean,
It relies on you being there, sweat equity,
Yeah.
which is, right?
People love to talk about, I mean, it's interesting. It's really funny because people love to talk about our work with respect to the hand. They love it. It's like this narrative that's attached to our...
I mean,
but
because it's
our
like
work
right
is no
there,
more-
I don't love it. I just like, it's hitting you over the head every single time you
Oh, the
take a
hand.
look at it.
Yeah.
You know,
Well,
so...
But I mean, in this case, but most things that are constructed in architecture are constructed by hand.
Yeah. I would say all things that are
a-
constructed in architecture are constructed by hand.
A Boeing 787 is constructed by hand. There's componentry which is fabricated according to extraordinarily small tolerances, but then there's always the logic of assembly and the logic of the hand and the logic of the logistics of putting things together that come into play, even in building the most advanced structures in the world.
But the question, however, is when the hand is still left as an imprint,
As an imprint.
which is
right.
very different
Definitely.
from, all
Sure.
of the things that you give example when you think it is machine made, but
Sure.
it actually is go through a,
Well,
production.
on a 787, you will never see the trace of the
That's
hand.
right.
That's
I mean,
right.
you don't want to see the trace.
And that's why I was
the trace of
alluding
the
to,
hand.
it's not
Right.
about your interest in
Right.
building things, we all do, but why do you leave that? Why do you want it to be evident?
I think part of this has to be with the fact that what we're using as the material. I mean, paper pulp is, by design, it's formless. It's just slop, and we call it slop for the most part because it doesn't have any kind of desire whatsoever. You have to form it.
This
And there's-
dire is just to fill space.
and there's
just to
lots
spread
of
out
ways to
buildings.
form paper. I mean, I took a couple of classes here with Yoshio Ikesaki many years ago, paper making classes here at SCI-Arc, and you use screens to make sheets. When you study the paper process and you look at the drink trays, and that was kind of one of the things that drove this project, were those drink trays, the strength of them, and the reusability of them, the fact that they're so lightweight yet you can put
Starbucks
4 drinks, 4 giant supersized Cokes on it, and they'll hold it perfectly. Those things were that drove a little bit of this also, but those things are mass produced.
But they
as
have a
well.
structural integrity.
Yes.
They don't need any spline to hold the piece up.
Well, we don't think ours will need that as well, and that's kind of one of the next steps, I think, in the evolution for this.
Right.
So, I think what you guys are looking at is maybe one step in where we would like this to end up, and what we would like this to end up is as a whole paper structure with no other material that kind of pollutes its concept as purity concept. So, ideally there would be no plywood here. But
you can't get to that point overnight.
Yeah.
I was saying this the other day.
The drink trays took a while to get to that.
There is no, if you have two kinds, if you can divide craft into a craft of certainty and craft of risk. Craft of certainty is framing a wall and putting sheetrock over it and slopping drywall mud over it and sanding the mud and taping it and painting it. It's been done for 100 years.
No, I call it that building. It has nothing to do with craft. It's like, it's just construction. It's not about craft. I think there's a big difference between craft and construction. Right?
Yes, but craft meaning that you're working directly with the material, the materials informing the way that you work, because the motions of the hand, the motions of the tool relative to the material haven't been codified, they haven't been codified. There's no rule book, there's no playbook. we didn't have a book that we could go to that said, this is how you spray paper pulp of this particular type that we were able to get in Los Angeles using the spray technique that we used. There's no book. So we have to listen precisely to what the material tells us each time we spray it. And if it makes them, if it produces results which are not exactly what we had anticipated, that is a learning experience. You fold that back into the next round. And so you have to go through multiple iterations in order to get to the point that you can actually achieve something so it becomes craftsmanship of certainty.
But on the other hand, we are talking about a kind of empirical process.
Yes.
Okay. And we would think that with the technology that we have at hand right now, that it is a much more I would say natural at this point to start mixing technique and materials so that you don't kind of build up the brick. And what I'm hearing, what you're saying is that your process is one which, of course, all experimentation, you try something, you fail, you try again, and you fail. On the other hand, I'm wondering why the material is the one that you use without thinking about additive, thinking about the strength of the material, or are you using the material because it is available and then you are just trying to test it until you learn what it can do as opposed to adding something to it?
Well, we use different, I mean, the material itself is not, I mean, it's paper pulp, but there's many types of paper that one can purchase, and those different papers have different structural implications. They have different possibilities, different ways you can exploit it. When we were playing with this, we played with many different types of paper. One of them was newsprint, and we buy paper from a recycler, so what you get is very consistently the same kind of scrap paper. So the very first paper that we played with was...
It's consistently the same if you buy
from a recycler.
If you buy a bale of a particular type.
Right,
but
which is what we do.
Multiple types of bales that you can buy. So if you shift from BSK to newsprint to coffee filter, each of those has different structural
Right.
properties, and each of them also has different properties with respect to how they're applied. So there's not just this general category of paper pulp. As we get deeper and deeper into it, we learn more about the particularities of the material.
And also the adhesives. The adhesives, like, I mean, in studying and doing this project, we learned quite a lot about adhesives. I mean,
So what do you see the application?
I'm sorry?
How do you see this?
For architecture?
Yes.
Oh, man. I mean, there's so many. I mean, I think that, okay, first of all, when we kind of pose this as, I think it's obvious that it could be used for disposable architectural applications. I mean, there's a whole industry of architectural scaled structures which are meant to last for a limited period of time and then are discarded or are they're folded up and go back to some event company. So that's that could mean event structures, that could mean pavilions, that could mean sets, that could mean point of sale, advertisements, whatever. There's a zillion kind of practical applications for it. But additionally, and it's interesting because it's made from a recycled material, and then it's also capable of being recycled again. It's capable of being composted. It doesn't produce the kind, but it has the potential to yield the kind of formal, the kind of shapes that maybe you could get out of fiberglass.
Yeah.
So, to me, that's very interesting. But that aside, from a permanent standpoint, that we're just scratching the surface. I think that if one were to build it up and to learn how build up the thickness and to learn how to panelize it in the right way and coat it in something, we're not sure yet.
Yeah.
Resins are toxic, so that conflicts with the kind of sustainability aspect of it. So maybe it could be. I don't know. We don't know how to code it yet to make it applicable
but
to
you were
permanent
because
setting.
you were using the kind of the S word, okay?
But even, I would even say
but
that
it's-
we're still even playing with that process, right? Because we're not quite certain that, say, for example, spraying paper pulp on a Volkswagen or on readily available formwork is the right approach, for example. It's part of the experimentation. I mean, we did wrestle with this, and there are other ways, because like I was saying earlier, the paper pulp in a sense is formless. So what you do with it between the moment that you made it and the time that it dries has a lot to do with the outcome of the form, I guess. You could say that, because it's very technique-wise, it's a very difficult material. It poses a lot more difficulties than, say, fiberglass would. Fiberglass, it's catalyzed chemically, so you are guaranteed that it's going to dry and that it's going to create a shell of a very known thickness. The paper, it will lose 90% of its weight in drying.
Of course,
right?
but I mean, the reason why I was, because Benjamin was talking about sustainability, and clearly it has all to do with recyclable, and then we all are caught up with this notion of being sustainable. But I was wondering if it has something to do with a certain ideology, or does it have to do with a certain novelty of trying with a new materials, the value of using recyclable materials. I mean, we've done it. I mean, there are wood. You have recyclable wood. You have
Sure.
there's a lot of other materials which are recyclable, and so we use it,
Sure.
and we test it out. We wanted to do pulp panel
Right.
for a very, very specific reason, for a specific application. But what you are saying is that you're interested in application which has to do with temporary, which has to do with, like being on an exhibit, trade show, and
Maybe.
all of those things.
That's one.
Maybe,
Yeah.
maybe. So you kind of blur between what I'm asking about, whether it is because you're interested in the material out of novelty, which is very different from using it for its specific.
Novelty is a very bad word for me, but it's not about novelty. I think it's just a genuine interest in the material,
Yeah.
because to just test what its technical parameters are. So we've used it to make lamps which are translucent, that emit light through them, and we sprayed them over Mickey Mouse balloons, right? So that was one use. We made a kind of a structure that was a kind of a pile, a kind of a heap, using Mylar balloons, spraying it over that. I think one of the ways, I sense you're getting at is like, what is the purpose? Like, what's the goal of using this particular material? There isn't one. And that's why we do it, because the more you work with it, the more you see.
The more purposes that you get.
So then, if you're not successful, then you would discard it and try another materials?
Maybe not necessarily another material. I mean, I think what we're wrestling with here is part of an interest in the material, the paper pulp, and not necessarily just because it's recycled and it's compostable and it's green or whatever.
We don't really care about it. We don't really do
You
that.
don't care about that part.
Less
You
that.
don't care about the sustainable. You don't care about using that, right?
Well, I mean, I got
I'm
a 2-year-old, so I do care that the world goes on forever. So,
I mean, but
that-
it could be applied to those situations. You know. That's one of its advantages.
But I mean, I think we're interested in the fact that it's accessible to not just to us, but it's accessible to a whole number of people. I mean, if you look at, we spend a lot of time looking at videos on YouTube and stuff, and if you look at the way that like those drink trays are manufactured, I mean, you're talking like a huge production line just to make something that's just like really going to be thrown away. So, and there's kind of the production, the setting up of the production to make something that simple. It's part of the limitation for this, the production.
But you're talking about a manufacturing process which is extremely practical, functional.
Yeah.
And the reason why you have such a large production is because everybody uses them.
Yeah.
You can throw them away or you can recycle them, but it's actually the most functional thing. Everywhere you go, you need one of those trays, right?
Yep.
So there is a certain kind of practical application to that. Whereas what you are suggesting is it could be practical or it could not. It may be functional, it may not be functional, because you're interested in how the panel, how you can use this material to make form.
Well, we're using it in a way that we're trying to take it to a kind of a custom level where it could be utilized in custom situations. Like he was saying, that a drink tray or packaging material, you're making multiples of hundreds and thousands, millions of these pieces, and they can be made at a fraction of a penny per unit when you amortize the cost of the tooling over that scale of production. We're trying to take that kind of material and apply it in a way where we can do something of significant scale with it for $8,000. So we're trying to develop a technique where we can and develop enough knowledge whereby we could, for instance, NC router a form for a panel, spray it over that panel and pull paper, spray it over that mold and pull a paper panel off of that, or spray it over a car, or spray it over a swimming pool. And we could exploit the form that already exists in the everyday world to yield architectural results. I mean, part of this is looking at the world around us as the source of form, as the source of molds.
Because as we know, the molds are the expensive part,
right?
And that's what actually takes a lot of the expense is the making of the form to do something, and that's part of the reason why we looked at readily available objects, cars, boats, swimming pools.
The part of the criterion and the choices was that it be iconic, that it represent the California suburbanscape, that would say something about Southern California. And
for this piece? Or
for all
the objects.
all of the three pieces. So in other words, if you were asked to do something in Boston,
Yes.
it would look different.
Yes.
then you would not use the mold of a VW.
We would go to Boston
using
and collect molds in Boston.
That's right.
So, and then in a sense, then you don't have to make the part which is difficult and expensive and time consuming. That's the idea so far.
So actually the idea that the form is recognizable and that it has a certain kind of metaphor and iconic form is really important for you.
It becomes an impression in a different sense of the literal kind of impression that those are. It becomes a kind of an impression of place. So in theory, if you were to combine multiple objects from a particular place, it becomes a kind of it has kind of symbolic meaning that
To
is
its
derived
location.
from of a particular environment from which these things were
I'm
derived.
very glad that you brought that up, actually, because that had been one of the things that we discussed. You know, we were like, well, if we do this someplace else, and the object selection obviously has to be, it's like you're almost curating, right? Like specific objects from that for that locale that you're working in or putting something in. So in a sense, you know, it could be it's very specific to its environment.
Which is something that also we were interested in with respect to how would that play within a context of where the digital abstraction, new forms of form that is generated through digital processes. How would that play within that kind of environment, which is SCI-Arc? Not as a kind of reaction, but as a kind of, maybe it's a kind of a provocation. You have a new technology. The technology enables you to capture form of anything. Nobody needs to model a bug anymore. They can go capture the form of a bug.
Well, I think my other question has to do with the technology itself, because this is clearly handcrafted, and we talked about robot, right? We've talked about how the robot could then start spraying and doing all of this. So then suddenly you're taking that whole notion of this kind of handcrafted, primitive way of looking at it to something which is highly precise, highly calculated, that you can completely control and take away any traces of human hand whatsoever.
I think that that's an interest. I think that tension is an interesting thing to play with aesthetically. I don't think that the expectation for design today to exhibit seamless machine rendered, and I mean physically rendered qualities is something that at this point in time is interesting to challenge.
So you're not ready quite to let go of the rein yet.
Look, no, because look at our oeuvre. You know, we've done things that bear no trace of the human hand at all. You know, somebody started talking about our work in the human hand a while back, and like some of it has it, but some of it doesn't.
We did a little bit. I mean, we always I mean, refer to the sense of craft, and I guess like, you know, that's like, I guess it's because we're realists, you know. It's like there's really no machine that we know of yet that, like, even a robot, right? You have to program the thing. So in a sense, it's not really doing whatever it wants or doing like the most accurate thing. It's just doing what you tell it to do. It doesn't do anything otherwise. It just sits there. So
Yeah, of course.
whether or not
but
it's
once
accurately,
you tell it what to do, then
That's
he
the
would do it
human,
in a way
yes.
that you can't do better than
in a
it
sense,
can
though,
do.
I guess what I'm trying to say is that it's a different trace of the human hand, in a sense, right? The human hand.
One is more intellectual, and the other one is.
Yeah, I mean, it's in the tool paths of the machine. It's in
And that will bear, as there is a history of that kind of work develops, you will decidedly see traces of the individuals that program those particular machines in the work. It hasn't been around long enough.
My grandfather used to make
It's
things,
like techno
you know,
music. Like, I can tell what DJ, you know, if you listen to enough of it, you know, this DJ made this, that DJ made that, electronic music.
Yeah.
It doesn't, this idea that you erase the author is, I don't know if I buy it.
And I think technology also leaves a lot to be desired, especially in this thing. I mean, and we were working with these guys. I mean, they had this machine that, like, and you know, I digitized things back in the day at like Gary's office by hand with a Faro arm, and you sit there and you put this pen on a point and go dook 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 dook, and you know, like, move along the surface and you make as many points as you want. Now you put this machine off, you know, 10 feet across, it goes like that, and it did a million points on that thing. You just didn't have to do it.
Yes,
but then
but-
you got to go back and take all of that info, and then somebody has to sit there and the hand comes in a different way because somebody has to sit there and they have to join all these things.
Well, there is a difference between the machine not being able to do what you do and that
Yeah.
you have to kind of finish it off. You know,
Eventually
we've seen
they will.
enough exhibits at SCI-Arc
Right.
where you have to end up kind of sanding and making the shape perfect, as opposed to another, you know, what you did here, which is to not use a machine and to say this is what it is because you're building it by hand. I wonder if there is something where the two are joined together, which is very, very different. I'm not talking about hiding, right?
Sure.
Hiding
Sure.
and saying that the machine is perfect.
Right.
Because the machine so far has been imperfect because you haven't been able to ask the machine to do something perfect because you still have to work at it.
Yep.
But this was made, I mean, this was made with a machine. I mean, this was made with a numerically controlled router. I mean, we have to take
You
the
can't
shape-
convince me to when I look at that,
all those ribs were cut
Yes.
based on a scan,
right?
and the machine cuts the ribs, and we assemble the ribs. They all fit together well. Any distortion, any tweaking, any warping is not due to the hand, it's due to the interplay of wet material against plywood. And unless you've done that before, you don't know that. It's gonna warp that plywood. You don't know what thickness of plywood you need. So there's no hand work in that. Where it pulls off, where it pulls away from the rib is a result of shrinkage. Where it has a rough deckled edge along where it meets the rib is a result of the way that the form is made and the material pushing under.
I understand all of that. However, if you were going to take a very scientific way of looking at this,
Right.
then you would be saying that having applied the layers and having been keeping track of how many layers and how many colors and all of that, then you would have this extremely precise measuring instrument that would measure all of the shrinkage
Sure.
to the millimeter, 10 millimeter, to understand how you're going to go about doing it with a different material next time in order to control the shrinkage, right? But I sense that there is a reluctance of you to go that far, to really get to that point of.
Greg, is there a machine that will measure the material and that will tell us how much it's going to shrink? Greg Otto,
No,
Pearl Harbor.
I'm not talking about measuring the machine, but talking about figuring out. Well, yes, of course, you can measure the.
You can't. There's some, you have to experiment with the mix, and you have to try it, and you have to go through the process of trying it over and over and over again until you develop enough empirical knowledge that you can start to graph, you could put it on a graph and call it a trend. We don't, that would take years.
Yes.
Material research. So we have to fall back on a craftsman's approach, which is try it, fail, try it, fail, try it, fail. You can go through maybe 6 iterations on something like this and do that many failures. But if you were to industrialize this, if that's what we're talking about, is to get to the level of polish that we would expect in industry, that would require years of research.
Yeah.
So, you know, this is
But
the
then-
first Eames,
But then
Eames pressed
what is
plywood
the goal?
prototype.
What is the goal if you don't want to industrialize it?
We-
Because
we-
then you're saying that you want everything to be handmade.
No.
As a
We will
single,
industrialize
as
it.
a.
We might industrialize it.
Okay,
Sure.
so that's why I'm trying to get to that end point, because otherwise, should we be waiting 10 years before this thing gets industrialized?
I think there's 2 ways to look at it. I mean, you could go. I'm interested in industry in the way that, and it's obviously you can move far beyond this. I'm interested in the way that say Gaetano Pesce used it, could use, if he would have taken his pieces into mass production, where he could control kind of the chaos of the materials, right?
Mm-hmm.
So there's a little bit of variation in each individual one. that would be something, that's one way you could take this kind of stuff. You could also take it to a super high level of refinement and make it repeatable to, you know, thousandth of an inch tolerance in the sense of the McDonald's drink tray. But the more we know about it, the more options we have. And it, you know, like when you become an expert on a material, you work with it, you become an expert, we could take it either direction.
How long do we have to wait?
Years. I don't know. Well, I mean, we've been working with this for we've been working with it for
Well, we've been working with it for, I mean, we've worked with it both in studios and in different, we taught it like a few different studios, which paper was the material of focus. And I think what we've always wrestled with is what do you spray paper against? You know, that becomes the big trick. What do you do with it? So in a sense, if you want to industrialize it, you have to kind of answer that question. That's the first question, I think, to answer.
We're working in a way that's, I don't think the bug is probably the thing you'd want to industrialize.
Industrialize at a scale that goes beyond what's already been done. I mean, obviously it's been industrialized as a drink tray holder. There's lots of different things that are made as a paper product that, you know, of sizable scales, but not like this. So I think like that's what we're wrestling with, and maybe that's why there's a trace of the hand quite often, and especially in this because it's experimental in a sense, because there is no other approach to it other than the hand, you know, in the beginning.
At this point.
Yeah. So, but.
I mean, you got to be willing. I mean, we have to be willing to take the risk. I mean, we were like okay with it being.
Well,
yeah, and the form also had to do with structure too.
I'm sure that you're never afraid to fail.
You look. I mean, I would prefer to fail on I would prefer to have a problem on or you know, have things deviate from our expectations on an $8,000 installation at SCI-Arc than $1.5 million.
We spent a lot of time though working on it
at another project. But I mean, I think that it's important to. I think that if you're going to explore materials the way that we do, you've got to work directly with them, and you've got to go through multiple iterations, and you have to. You're not going to get perfect results for a while. It takes time. It takes because, like I said, there is not a rule book, and I think that if we were, you know, we wouldn't be. I don't think we would be learning as much if we were to do projects which we always knew exactly how to do.
Yes.
I mean, part of our, you know, one of the things that's really been important to us is that we feel sufficiently challenged and each project, and that we don't just produce a kind of demonstration of pat techniques that are you know, gleaned from some, you know, architecture studio at Columbia University or something. You know?
Well, this is, I think this is a perfect segue to say that it's very a SCI-Arc way of doing things. Right?
Yeah, we didn't think you guys were going to sue us if, like, for example, when the pool didn't turn out. It's like,
no,
oh,
I don't think. I think we have seen more kind of dangerous thing than that. It's not falling anywhere. Anyway, thank you very much for the conversation. Thank you.